Okay, we continue our keynote series featured speaker. So I'd like to introduce the CEO of Altiscale, leading big data cloud platform. Previously, this featured speaker was at Yahoo. He played an instrumental role in algorithmic search, display advertising, and cloud computing. He also helped set Yahoo's open source strategy, initiated its participation in the Apache Hadoop project. Prior to joining Yahoo, he founded Stata Labs, maker of Bloomba's search-based email client, which Yahoo acquired actually in 2004. He's also worked for Digital Equipment System Research Center, where he contributed to AltaVista. I have used AltaVista extensively prior to Google, AltaVista search engine. He received his PhD in computer science from MIT in 1996. Everyone, please welcome Rami Stata, CEO of Altiscale.
So, I want to talk about big data platforms. AltaVista, right? Altiscale is, I would say, definitely one of those partner firms for financial services companies. We deliver big data infrastructure as a service in the cloud. Now, we've been hearing, a lot, I think, about data and Hadoop and Spark. Lots of big numbers there. And a lot of adoption now in the broader enterprise. And companies like Yahoo and Google and Facebook, Twitter, for example, have been at this for 10, 15 years. But what's interesting now is the broader enterprise, as we call it, is adopting these technologies. And really, financial services as a sector is kind of leading that charge. I think second to those internet companies, the financial services industries are adopting the big data technologies. Now, there's the infamous hype cycle, and there's Hadoop on its way to the trough of disillusionment. However, it turns out that the hype cycle for big data has been retired. And the reason is because it turns out that the hype cycle really is for technologies that haven't gotten any traction. Once a technology gets adopted by about 20% of, again, what I call the broader enterprise, Gartner says, hey, it's no longer kind of on the hype cycle. It's now really, truly becoming still an early technology, but a real technology and not just a hyped technology. So it's becoming real. I think this slide here, or the message I want to deliver here, is probably one of the most critical ones. I mean, I think on his way out, Andy said, hey, what's different this time around? And I think with respect to data technologies, we can ask this question. What's different this time around? There's been a very long history in all of industry, quite frankly, but certainly in the financial services industry, around adopting kind of new waves of IT. I think the critical difference here and what is really different is that the data that people are absorbing increasingly is coming from outside the firewall. We're no longer simply looking at our own internal systems, our ERP systems, and saying, hey, what does my ERP system tell me about the world? Your ERP system tells you relatively little about the world out there. And what's happening is that the world is getting instrumented, and you're able to pull in data about what's happening out in the real world into your organization. And you're able to build feedback loops and real-time responses to that data. If you think about the internet, it was inherently instrumented from the very beginning. And so I think it's no surprise that the internet was kind of a pioneer in these big data technologies and the business models that real-time data collection can drive. But again, as the rest of the world becomes instrumented as deeply as the web has been instrumented, I think a lot of those techniques will carry over. Now, I will say, probably one of the bigger blockers to adoption of big data, or really getting business value out of big data is changing mindsets about business models. And again, we heard a great anecdote about that with respect to the 30-second loan. And you could just imagine, like 5 years ago, somebody in a big bank saying, hey, I got an idea. Let's figure out how we can approve loans in 30 seconds. And people would have looked at them like it just wouldn't compute. And I had a similar experience. I was at a CIO dinner, happened to be sitting next to the CIO of a large hospitality firm. And in the world of the web, and especially sponsored search, which I had a lot of experience with, of course, dynamic pricing is a big part of what we did. So I said, hey, do you think dynamic pricing might have, a role in the future of revenue optimization for hotel chains? No, absolutely not. That was tried in the 1950s. It failed miserably. That's just a really bad idea, right? And the business models and what's considered the right way to do things is so entrenched that somebody saying, hey, let's approve loans in 30 seconds. I mean, those kind of ideas just can't get considered, and that blockage is what I think gets in the way. But the fact of the matter is that these new data sources allow us to question and to change ultimately these deeply entrenched business processes. So again, the new data that's coming in is, I think, going to revolutionize all industries. And we've all seen the 3 V's, right? Volume, variety, and velocity. And it's the nature of these new data sets that make it really inapplicable, or the old data technologies kind of inapplicable to them. What I thought I would do is go through a few use cases from the financial services industries of where we're beginning to see people use new data sets to change old processes. Here, this is kind of interesting. This is for the bank in India, where they wanted a new approach to kind of assessing systematic risk. And so they were able to go out and build a very complex graph model of all the organizations that the bank was exposed to, and create a risk model based on that. And the challenge here is that they actually consumed a lot of textual data and tried to pull signals, basically the nature of those edges, out of textual data on the web, textual data in regulatory filings, and so forth. You can do that by hand, but you're inherently kind of limited in terms of how much you can pull. If you do it mechanically through machine processing, you can build a much deeper web, if you will, of relationships. So here's where kind of the variety and the non-structured nature of the data is kind of new as people looked at an old process. Here we've got a hedge fund, a very successful one. As is the nature of these things, they don't like a lot of details being given out on what they did. What was interesting in this use case was, again, using a lot of unstructured data that's found in regulatory filings and on the web. But here they combined it actually with some real-time signals from the markets. A third use case actually is quite relevant to, again, the talk we just gave, where one of the intermediaries in the payment space has a very rich, very long history of transactions, and is looking to basically monetize that data set by developing reporting and other kind of signals from the market based on a huge amount of consumer transactions that they see. In this case, really, it was the volume of the data that was a particular challenge, where there's just literally tens and growing to be hundreds of terabytes of data that they want to put together into these reports. So this we go a little bit in more detail on, right? So here's kind of the product that I just described for you, here they had an existing product that worked on very aggregate data, And typically the nature of moving to the big data solutions very often is to analyze your granular data in ways that you never have before, right? So in this case, the transaction by transaction data, and providing end customers the ability to actually navigate data down to that fine grain. And so that was their challenge. If they were to do it on their kind of existing technology, it would just be cost prohibitive. Part of the challenge of big data is that it's big, and when you multiply large number of bytes times a very large number of bytes, you get to be huge numbers. And so they really needed to move to a technology that was fundamentally different in that cost spectrum. So they went to AltaScale. Really just think about that as going to a Hadoop-based platform, right? And Hadoop and these new big data technologies, live in a very different point in that price space. And so they were able to meet their product objectives and move forward. What we have here is kind of an interesting deep dive into their experience in moving from traditional technologies to big data. In this particular application, there is kind of a large batch job that they have to do on a periodic basis. A version of that existed on older SQL technology, and they were porting it over to the Hadoop-based technology, to Spark. They gave themselves the existing technology could finish a batch in 6 hours. They kind of assumed in the beginning anyways that it would take longer, but it was less money, so they thought that was the right trade-off. So they had a budget or an SLA of 24 hours for this job to run. Their initial implementation, however, took 2.5 days. And they were in a panic, like, oh my God, what are we gonna do? And so they got us involved because they're like, hey, your Hadoop implementation is broken. This is not what we were expecting. And so we went and we looked, and basically they took the exact same kind of way they formulated the job in the traditional technologies, and they simply just brought it over. No change whatsoever. And that kind of direct movement of the code, it didn't perform. And it really got us to realize that these technologies, they are different. Even though SQL's involved, there's a lot of characteristics of the technologies that's different from what people are used to when they come from the database world. And so in this particular case, we decided to put together a workshop. It wasn't long, it was about 2 hours long, where we basically went through a little less than 24 kind of tips, right? If you're used to using MPP SQL, here's how you use Hive and Spark SQL better. And so on the basis of that, they went and they rewrote their application by themselves with no or little additional input from us. And when they were done, it went down to 2 hours. And so not only did they beat their 24-hour budget, but actually they were able to beat the amount of time that it took in the existing technologies. So I guess the story here is they both got a cheaper technology and a technology that could get the job done faster, but there is a learning curve to this stuff. And sometimes, for example, in particular, the use of SQL as an interface to these big data technologies can be a little bit of a hazard because people think that all SQLs are equal. So, and the person who owned this was a happy customer of ours. So I want to come back to the big data technologies, Hadoop and Spark kind of being the poster children for that. One thing I mentioned in passing, but I want to emphasize, is the importance of the cost basis of these technologies. There's a great definition of big data by George Dyson. He said, big data is what you have when it's more expensive to decide what to throw out than it is to just keep it all, right? So there's this kind of price point where at some point you keep stuff speculatively and find the business value through an exploratory very bottom-up process, versus, if it's expensive to keep everything, then you kind of have to make the business case before you build the infrastructure, and that becomes very hard to do. So that price point when you get to these large data volumes, and that ability, again, to bring in a lot of data speculatively and to explore in a very agile fashion is really, really critical to, again, one of the things that's different about big data versus older technologies. But the truth of the matter is that even though the broader enterprise is increasingly adopting these big data technologies, at the same time, they're having a very difficult time being successful, in their implementations, of that. And again, I think the story I just said about the naive translation of those existing SQL codes is one of about a million ways that things go wrong, and contribute to an unfortunately high failure rate. And I think it's one of these issues where people sometimes don't know what they don't know when they're first getting into, say, Hadoop or Spark. They don't quite understand, the complexity that they're in for. And so we've put together what we call the curve of complexity to help people kind of understand just, why this is different as well in terms of its technical complexity. So, first of all, it starts with the hardware itself and the type of scale-out infrastructure that you need to be successful with big data technologies, and even just the sheer volume of what's needed to make that work is often a challenge for traditional IT organizations. So in the cloud, you kind of have a solution with an infrastructure as a service, kind of like an Amazon, where you can get a bunch of VMs. Although those VMs are not particularly optimized for Hadoop, nonetheless, at least you can get them. So then the next problem is you got to get Hadoop and Spark up and running. And again, when you're talking about many tens to hundreds of nodes, simply bootstrapping that kind of distributed system becomes a challenge for organizations. And so what's evolved has been a lot of what I call big data bootstrap solutions. So Elastic MapReduce EMR, which is Amazon's product, I think is the granddaddy of these things, where with an API call you can get you get a smallish Hadoop cluster up and running pretty quickly. If you want to get a large cluster up and running, that's a whole other story. And now it seems like at least every month there's somebody else who has a new set of scripts, right, that can get a Hadoop cluster up and running, on infrastructure as a service for you. And what I think is very unfortunate is that many people consider that Hadoop as a service, right? They say, and is once it's up and running, that's automated, that's done, and you're good to go. And as the curve is kind of indicating here, that turns out, however hard it is, and for on-prem, we've seen people, take 9 months to get to just this phase. However hard that is, that's just the beginning. And unfortunately, people don't recognize what comes next. What comes next is you got to keep it running in production at scale. And what happens in some sense is that there's always a success disaster with these scale-out infrastructures where it's successful, you bring in more data, you bring in new applications, and things start to fall apart because distributed systems are inherently difficult to operate. And as you scale them out, failure rates go up. And unfortunately, it's one of these kind of death by 1,000 cuts kind of situations. It's not like there's this one problem and if you fix it, all goes away, right? But you get performance tuning issues, you get, Hadoop likes to throw, and Spark does too, likes to throw stack traces. There's no error message, you got a stack trace. What's a shame actually is to see data scientists spend, 2 or 3 days searching the web, right, to interpret some Scala stack trace, right, because they have a syntax error. Like, I'm not kidding you, it's that bad. Components get broke, jobs get jammed all the time. Like a job that worked yesterday hangs to tomorrow for mysterious reasons. And so you see folks who have kind of an initial burst of success with Hadoop, and all of a sudden stuff just kind of comes crashing down on them. And then it gets worse because the big data ecosystem of software is evolving at a ferocious pace. And so if you want to take advantage of all this cool stuff you're reading about, you got to keep your software up to date. Well, updating your Hadoop cluster twice a year and your Spark, software once a quarter is just not something that most IT organizations are able to do. And this this just kind of kills them. Now, I want to talk about another element of what fits into this larger kind of curve of complexity story, which is particularly relevant to the financial services industry, and that's security. Because security definitely kind of plays a big role here. This is an important point, to understand across the board when it comes to IT and security. At any point in time, an organization has kind of a fixed curve of agility versus security. And as you try to move faster, you inevitably compromise security, according to some curve, and vice versa. As you try to get more secure, things slow down. And what I have seen is people think like they don't realize they have this. And again, this is a static view of the world. But then you get people starting to fight each other. We got to go fast, we got to go fast. We have to be secure, we have to be secure. And you get these big kind of battles within organizations because they're living on this curve, and some people value security and some people value agility. Now, the fact of the matter is, through investment, you can shift the shape of that curve. Maybe not quite as much as this diagram suggests, but you can, with investment, you can get to the point where the trade-off between security and agility goes down, and you can kind of get the best of both worlds. But you have to be willing to make investments. Now, here's where it all kind of connects back to Hadoop. If you take a naive implementation of Hadoop, the curve looks like this. You get either security or agility. It's binary. Because getting all of the security kind of turned on properly and working and connected into your LDAP system and everything else, right, that would make security actually easy to use, is really hard in the context of Hadoop. And actually, when you use object stores, whether it's at Amazon or other places, this is even worse because a lot of the security features that are in HDFS don't even exist there. So going back to why Hadoop is deceivingly difficult, again, in the context of financial services, this is another really critical element. So coming back to this curve, right, the point is, to be successful with these technologies, it takes a lot of expertise, a lot of time. And so I think the good news is we happen to also be not only in the era of big data, but the era of cloud computing. And our view at Altiscale is that you really want kind of a managed big data service. You don't want to do this at home. And I think the people who have tried have the bruises and the cuts and the scrapes to kind of prove that point. If ever, right, there was a technology that was just begging for a cloud-based delivery, and a cloud-based delivery that doesn't stop at the Hadoop Bootstrap, but is fully managed for all aspects of the service, this is the one. If that makes sense to you, let's kind of go through some of the considerations that go into selecting such a service. We got them all at once here, but let me just kind of cherry pick a few of these. Expressive for users and simple for administrators, right? Simple for administrators means all that stuff on that curve of complexity is hidden from them, right? It just gets taken care of. And all the administrator does is add a user to the cluster and put them in groups, that imply certain security controls. But at the same time, expressive for users means, the way I like to describe this as fully accessorized, right? There's a lot of tools, a lot of components that surround kind of the Hadoop and the Spark ecosystem. And you really want an environment where that's all kind of pre-configured so that your data scientists and your business analysts and your developers can really just focus in on using these technologies and not either having to use very, very primitive tools, or having to bring in the convenience tools themselves. Data at rest stored in HDFS. I think I mentioned one critical reason for that. Object stores don't have the security features that HDFS has. In addition, there's a lot of performance benefits to HDFS as a store. So having an always-on, if you will, HDFS that's home base for data we think is really critical to a good managed Hadoop solution. Hadoop as self-configuring, maybe a better way to put this is kind of self-tuning, right? Like just think about nodes in the cluster. You know, what size nodes? How many? How's the operating system kind of configured? As your workload shifts, you know, how do the 1,000 Hadoop tuning parameters get changed? There's a lot to keeping a Hadoop cluster kind of running well, and you really want a service where that's all taken care of for you. Elasticity. Obviously, if you're going to the cloud, you're looking for elasticity. And so you should look for a solution that provides that. But I think in the context of Hadoop, you really want elasticity that's delivered at the Hadoop level. All you're doing is submitting jobs, right? And as more capacity is needed, it magically appears, right? And in fact, in some sense, you don't think about capacity. You just submit jobs and they run. You know, in contrast, again, to having to manage nodes, right? If the word node ever comes up between you and your Hadoop vendor, maybe you're operating at the wrong level of abstraction. Non-stop operations. You know, the truth of the matter is that distributed algorithms, I mean, if you think about what, say, Spark or Spark SQL does, you know, a data analyst or a data scientist who knows maybe nothing about distributed computing is writing, you know, maybe this much text that gets turned into automatically a distributed program that operates, you know, across hundreds to thousands of nodes. You know, it's actually a pretty amazing thing. Now, the fact of the matter is that any program running on hundreds of thousands of nodes is inherently fragile, right? There's just the possibility for failure when you bring that much infrastructure to bear is so high that there's just a very inherent kind of tendency for stuff to fail as you scale up. And so what nonstop operations means is that you've got an operations team and regime that's kind of always there to fight the entropy and to fight failure and to make sure that those little scripts that get turned into 1,000 node applications actually get to completion. Number 6, I alluded to in that curve of complexity, where, again, there's just so much change and so much innovation happening in these technologies. You should put a premium on a service that not only keeps itself up to date, but keeps you up to date, right? So just throwing software at you is not going to keep you up to date. You know, actually having a change management process that allows you to absorb this kind of change and flexibility, right, in terms of when, what happens to kind of match with your development cycles is really critical and really actually, quite frankly, difficult to do. You know, cost transparency, you want to know how much is each job costing you, because at the end of the day, there's real costs associated with, you know, storing hundreds of petabytes of data and running applications on them, and you want to allocate those costs to different projects so you can understand who's costing you what. You know, job tuning goes hand in hand with nonstop operations. You know, for those very large, complex jobs, you want to have a team, you know, that can help you tune them at the higher scales. And that kind of bottoms out on, you know, you want a team behind you that just has a lot of experience with running big data applications and keeping that infrastructure, you know, up and running and very reliable. So we have a white paper that kind of goes through this. If you come to our booth, we can get that into your hands. But that leaves us with a few minutes for questions.
Okay, great. Thanks, Rami. Any questions? Can we get the handheld mic, please, so that we can get it recorded? But any questions for Rami? Yes, go ahead, Jimmy. I'll stand. Yeah, go ahead.
So you talked a lot about infrastructure and data, big data, and all that. Can you comment on the role of machine learning and deep AI in platforms?
Sure. So the question is, where does machine learning, deep learning in particular, fit into the platform and the infrastructure that we talked about. I think, basically, this infrastructure essentially was invented to support machine learning at scale, right? It was invented for web search, where for the relevance problem, and then later on for the sponsored search problem, which is even more interesting, machine learning needed to get applied to just tons and tons of data. So Hadoop and later Spark were invented, essentially to support large-scale machine learning. Deep learning is a newer kind of evolution, and I think the ultimate mashup, if you will, of deep learning and big data is still a little bit of a work in progress, quite honestly. But on the edges, people are kind of doing that. I think if you go back to the business case for big data, if you will, which is collecting all of this information that's happening out in the real world, and turning it into real-time signals that can be used to drive real-time business actions. There's so much data, and its interpretation is just impossible, right, for the human to do. It's almost implicit in that problem setup that you're going to have to use machine learning, signal processing, and those kind of advanced algorithmic techniques to actually go from all of that input into something that's actionable. So I think it's kind of embedded in